According to the 2020 National Electrical Code, specifically Article 250.142a, the grounding electrode conductor is required to be connected to the equipment grounding conductor and the neutral conductor at the service entrance. Article 250.24 further clarifies that the neutral conductor shall be connected to the grounded conductor of the electrical system and to the equipment grounding conductor at the service. Additionally, Article 250.116 permits the grounding electrode conductor to be connected to the equipment grounding conductor at the main service disconnect or service entrance. Based on these code requirements, the number 4 grounding electrode conductor should be terminated on the equipment grounding bar in the main circuit breaker cabinet. This provides a proper equipment ground and maintains the reference to ground for the neutral conductor. It's crucial to understand the function of each conductor and their interconnections within the electrical system. The grounding electrode conductor connects the electrical system to the earth, providing a low impedance path for fault current. The equipment grounding conductor provides a path for fault current back to the source, allowing overcurrent protective devices to operate and clear the fault. The neutral conductor carries the unbalanced current in a 3-phase or single-phase system and is intentionally grounded at the service entrance. The point where the neutral is bonded to ground at the service entrance is critical. It establishes a common reference point for the electrical system and ensures that all metallic parts of the electrical system are at the same potential. This reduces the risk of electric shock. Now, to address a specific installation scenario, where there are 12 200 amp meter positions with disconnects fed from a 1200 amp 208 volts 3-phase 4-wire main breaker service, and the feed to each unit transitions from heavy wall conduit to polyvinyl chloride conduit underground and back to heavy wall conduit as it enters the panel, and that a number 4 conductor runs from a ground log in the meter cabinets to the grounding bushing for that run, continuing with that pipe run to the panel and then to a grounding bushing there. The question arises whether the number 4 conductor should be terminated on the neutral bar with a bonding strap or on a lug on the panel cabinet. As established by the National Electrical Code articles previously cited, the number 4 grounding electrode conductor should be terminated on the equipment grounding bar in the main circuit breaker cabinet. The concern that the neutral loses its reference to ground when the pipe run transitions from heavy wall to polyvinyl chloride conduit is not the determining factor in this case. The grounding electrode conductor's primary role is to connect the electrical system to the earth, providing a low impedance path for fault current. The equipment grounding conductor, which runs with the circuit conductors, is responsible for providing a path for fault current back to the source, enabling overcurrent protection devices to operate. The transition from heavy wall to polyvinyl chloride conduit and back to heavy wall conduit does affect the equipment grounding path. Heavy wall conduit, when properly installed, serves as an equipment grounding conductor. Polyvinyl chloride conduit does not. Therefore, when polyvinyl chloride conduit is used, a separate equipment grounding conductor must be installed. In this case, the number 4 conductor is serving as the grounding electrode conductor, not the equipment grounding conductor. It is connected to the grounding electrode system, which includes the main water pipe and the supplemental grounding electrode. There is an exception in Article 250.24f that allows for the neutral conductor to be used as the grounding electrode conductor under certain conditions. However, this exception does not apply in this case since the neutral is already bonded to a main water pipe and a supplemental grounding electrode. The reason for this is to avoid creating parallel paths for neutral current, which can lead to circulating currents and potentially create safety hazards. The National Electrical Code mandates specific requirements for grounding electrode systems, which include the size and type of grounding electrodes, the size of the grounding electrode conductor, and the methods of connecting the grounding electrode conductor to the grounding electrodes and to the electrical system. These requirements are intended to ensure that the grounding electrode system is effective in providing a low impedance path for fault current. It is also important to note that the equipment grounding conductor must be sized according to Article 250.122 of the National Electrical Code, which bases the size of the equipment grounding conductor on the size of the overcurrent protective device protecting the circuit. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. This ensures that the impedance of the grounding path is minimized. In summary, the number 4 grounding electrode conductor should be terminated and the equipment grounding bar in the main circuit breaker cabinet. This provides proper equipment ground and maintains the reference to ground for the neutral conductor. The transition from heavy wall to polyvinyl chloride conduit and back to heavy wall conduit does not change this requirement. It is essential to follow all applicable codes and standards when installing electrical systems. The National Electrical Code is a comprehensive set of rules and regulations that are designed to ensure the safety of electrical installations. By following these rules and regulations, electrical contractors can help to protect people and property from the hazards of electricity. When dealing with electrical systems, it is vital to understand the purpose and proper installation of grounding and bonding. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting all metallic parts of the electrical system together. Grounding provides a low impedance path for fault current, while bonding ensures that all metallic parts of the electrical system are at the same potential. Both grounding and bonding are essential for safety and for the proper operation of electrical equipment. The size of the grounding electrode conductor is determined by Article 250.66 of the National Electrical Code, which is based on the size of the service entrance conductors. For a 1200 amp service, the grounding electrode conductor is typically a minimum of number 3/0 copper or number 1/0 aluminum. However, the actual size may vary depending on the specific grounding electrode system. The grounding electrode system must consist of one or more grounding electrodes. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. The grounding electrode conductor must be connected to the grounding electrodes in a manner that ensures a permanent and effective ground. This can be accomplished by using exothermic welding, listed pressure connectors, or other approved methods. In addition to the grounding electrode system, the National Electrical Code also requires that all metallic parts of the electrical system be bonded together. This includes metal raceways, metal enclosures, and metal equipment. Bonding is typically accomplished by using bonding jumpers or bonding screws. Bonding jumpers are short lengths of wire that are used to connect two metallic parts together. Bonding screws are special screws that are designed to make a secure electrical connection to a metal enclosure. The purpose of bonding is to ensure that all metallic parts of the electrical system are at the same potential. This reduces the risk of electric shock and helps to prevent the buildup of static electricity. The equipment grounding conductor plays a critical role in providing a path for fault current back to the source. The equipment grounding conductor must be sized according to Article 250.122 of the National Electrical Code, which is based on the size of the overcurrent protective device protecting the circuit. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. This ensures that the impedance of the grounding path is minimized. In the case of a fault, the fault current will flow through the equipment grounding conductor back to the source. This will cause the overcurrent protective device to trip, interrupting the circuit and preventing further damage or injury. Without a properly installed equipment grounding conductor, the fault current may not be sufficient to trip the overcurrent protective device, which could result in a sustained fault and a potential fire hazard. The National Electrical Code also requires that all equipment be properly grounded. This includes appliances, tools, and other electrical equipment. Grounding is typically accomplished by connecting the equipment to the equipment grounding conductor. This can be done by using a grounding plug or by connecting the equipment directly to the equipment grounding conductor. Grounding helps to protect people from electric shock by providing a path for fault current back to the source. In the event of a fault, the fault current will flow through the grounding conductor back to the source, causing the overcurrent protective device to trip. This will interrupt the circuit and prevent further damage or injury. It is important to note that grounding is not a substitute for insulation. Insulation is the primary means of protecting people from electric shock. Grounding is a backup safety measure that is designed to protect people in the event of an insulation failure. It is also important to regularly inspect electrical systems to ensure that they are properly grounded and bonded. This includes checking the grounding electrode system, the equipment grounding conductors, and the bonding connections. Any deficiencies should be corrected immediately. In conclusion, proper grounding and bonding are essential for the safe and reliable operation of electrical systems. By following the requirements of the National Electrical Code, electrical contractors can help to protect people and property from the hazards of electricity. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements. Understanding the principles of grounding and bonding is crucial for ensuring electrical safety in residential, commercial, and industrial settings. Grounding electrode systems must be installed correctly and maintained to provide a reliable path to ground for fault currents, protecting both people and equipment.